Hello fellow Blender users, in this video I'll try to explain how to use two operators designed to project meshes onto a surface and a third operator that can mirror a mesh over a surface. I hope you will find them useful. So to start off, I'll be showing you the operator that can project along the camera view, and to use it you'll just select the mesh to project, select the target surface, align your camera angle, and then call project meshes onto active. As you see, the mesh sticks quite nicely to the surface, and we had a quite thin mesh, so it has a quite thin edge, but you can always make it thicker. And you can also move the mesh along and add a bit of an offset, and the mesh floats a bit from the surface. You can also move it in the other direction and it will sink into the surface. This will solve any floating problems you may have, but as you can see it works quite nicely. And so we also have to note that if you have a low angle to the surface, the mesh will be smoothed out or stretched out a bit, but it is to be expected. You also have to note that this is quite similar to the snapping feature, but it will also retain the depth of the mesh. And that's it. We have a mesh that sticks quite nicely to our surface, and we can move on to the next operator. To show you the second operator projecting objects onto a UV map surface, we'll be using a cubish looking object like this with a seam in the edge here, so that the resulting UV map doesn't have any distortions, as distortions will cause the projection to distort as well. And the operator works by projecting the corners of the box encapsulating the mesh and then finding a rectangle representing that encapsulation on the UV map. And to use it, we'll just select our object and then select the surface and call project meshes onto UV surface. As you can see, the mesh is placed along the surface, and we can also move it over the UV map like this, and we can also rotate it on the UV map and we get a slight rotation. We can also scale it and we get a nice scaling on the surface as well. We can also, you also have to note that if you move it over the seams we had in the edges here, the projection will stop working. So if you move it a bit slightly more, the projection will not work well. And lastly, we have a option called keep relative scale. This will make the target rectangle have the same scale ratio as the initial mesh. So if we scale it, it will be slightly more of the form it had initially. And we also have a setting called partitions per face. So if you have a dense target surface mesh, it will help the other operators or other settings update a bit faster. As long as you don't have a source mesh that's fairly dense, then it won't help you that much. And lastly, we have the option called surface alignment, and it determines how the object is placed on top of the surface. And to show you, we'll go over here where we have a monkey, and if we would want to project it from the angle looking like this, and we choose the first setting called axis aligned, the monkey will be placed using the axis looking like this. So it will be placed on surface like this, and the y-axis will be pointing up from the surface. If we choose the camera view setting instead, we would project using a box looking like this one here, and the ear would then be placed, or the right ear here would be placed quite far from the surface, and the left ear would be placed directly on top of it. And lastly, we had an option called Z_is_up, which works similarly to the first one, but it will always choose the Z-axis as up, so it will be placed on the surface with the rotation looking like this, and it would have the mouth facing down toward the surface. And we also had this option for the first operator. It works slightly different there. Mainly it is that if when you use the axis aligned, it will project it rotated. So if we project it like this, it would actually be projected like this. So you have to note that when you do it, but it will also make sure the mesh is placed on the surface and not placed in a weird way. But it will not always look as you expected. And that's pretty much how the two first operators works. I'll show you a few demonstrations how the second operator can be used. So if we have a scenario looking like this, where we want to wrap a pattern around a cylinder like this, with a UV unwrapping with a seam down here, so it is nice and square. We can, and before we call the operator, we just have to apply the modifiers we have on it, and we have an array modifier, and it generates a lot of geometry that will not get projected, so we have to apply it. And then we have a subsurf, and it largely works on the surface of the object, so it will not affect the projection, and we can leave it. So if we just go and we have our origin point of the mesh far over there, so we have to move it onto the middle here, so it's over our target surface. We just use origin to geometry, and we can just select the meshes, project mesh onto UV surface, and it wraps around our cylinder nicely. You have to note that we have a gap here. It doesn't help you to solve this issue perfectly, but we can scale it a bit so it gets a bit closer, and getting it closer than that is quite hard as it cannot move over the seam, but you can always just connect it there or do whatever you want. It depends. You can always use a curve instead if you like that. I think this method is fairly simple. If you had a cylinder with a nice UV wrapping, it's just point and click. And that's it for this wrapping around the cylinder. We can move on to our next subject. That is our vase here. It has a unwrapping looking like this. And I'll just select the part it will be projected onto, and as you can see, it has a bit of distortion if we look down here, but I'll go into it a bit later. I'll just show you the projection result first and project mesh onto UV surface. It's not the fastest initially sometimes, but while we get to when we have done the first, the settings hopefully is a bit faster. And we had our scale from our last example. We will just remove it, and we have our result. The projection is slightly larger because our operator found the target down here, so it scaled it up a bit perhaps, and the map is slightly distorted, so it got a bit of distortion, but the pattern is largely intact. It has a bit difference. We can always scale our x-axis, that I think is the most affected, or down a bit, and we will get perhaps a bit closer to our initial pattern. But yeah, as you can see here, we can also move it toward the left if we wanted to. and it works quite nicely, but as we can see, if we go onto our UV surface, when we project, it will find a target perhaps in this rectangle here, and it will find a target looking like the selection here a bit, where and the UV map has not a lot of distortion in the middle here, but if we would have moved the rectangle to the left here more, it gets a bit more and more distorted. As you can see, if you had a rectangle like this, it would not project well onto the surface, but it depends. If you have a complex surface, the unwrapping method perhaps will not help you a lot. It can also help you generate specific patterns on your mesh if you wanted that. So distortion is not always that bad. I show you how I use these distortions on to generate a mesh, but that's another video, and I think that's enough for the surface projections. If you ever wanted to project a mesh onto a surface, they will probably help you with that, and we can move on. To show you the last operator where we can mirror a mesh over a defined surface, we'll use this monkey and mirror it over this plane. We do it by selecting them in order with the surface last and call mirror mesh over defined surface. As we can see here, we have a nice mirror on the other side of the surface, and each vertex will keep the distance from the face in the surface it was mirrored over, and we can control the mirror a bit by changing the settings. We only basically have one setting here mostly, and it's smooth. If we uncheck that, it will be a bit rougher because the vertices was mirrored along the normal of the face was mirrored over, and if we have it checked, it will be smooth between the adjacent faces. And we have the next setting. It's mainly a culling option, so if we had vertices on the back side of this surface, they would not be mirrored. If we go for intersecting vertex only and we go to this view, if we have a vertex outside the surface and the checkbox is checked, they will not be mirrored either. And lastly, we have a expensive option here that we usually don't want to use. But if we have a scenario where we have the face here and we have a lot of the mirror will be mirrored along the blue lines we can see here, and if we have a lot of intersecting lines like we have here, they will start fighting over which face the vertices should be mirrored over, and it will usually not look very nice. But if you have the expensive option, it can help it a bit by taking the closest face, or ensure that the closest face that to the vertex is used. It can help the result, but it usually won't, so I wouldn't really use that option or rely on it. And yeah, that's it. We have a mirror on our little funky curved surface here, and it is mirrored a bit like you would see in a curved mirror too. And if we go to another scenario, or we go back to our previous scenario where we had this pattern on the base, and here we can use the mirror option if we want to. And first we have to note that the mirror operator does not work if we have a width on the mesh, or yeah, it has some kind of substance to it. So we have to define a flat or surface or a shell here, and we can just use the one we have made. And as you see now, we can just call the operator on this surface here, and we will have a mirror on the backside of this surface. And the operator is quite nice if you ever had the problem of creating a mesh and realize that you want to mirror it after you have created it, and you realize the x-axis or the standard axis is not enough, you can use this operator by defining a surface you want to mirror over. And that's it. Enjoy.